Hello, this video is on lesson 1.4 and it's going to be talking about inverse of functions. Okay, so this starts on page 47. Now what I had you do now is basically just go over the process of reverse PEMDAS. Remember reverse PEMDAS, you start with addition, subtraction, multiplication, division, exponents, and then finally parentheses. So if we want to go ahead and solve this, you basically look for addition or subtraction. You don't look at plus 30 because that's inside the parentheses. So if we have subtraction minus 18, we're going to do the inverse or the opposite, which is to add 18. And whatever we do to one side, we must do to the other. So here, minus 18 plus 18, that becomes 0. So what we have is 5x plus 30 is equal to 17 plus 18, which is 35. Alright, no more addition or subtraction. We do have multiplication because we're multiplying by 5 here, so the inverse of multiplying by 5 is to divide by 5. Okay. And so 5 over 5 basically becomes 1, and so this is x plus 30. And so 35 divided by 5 is 7. Alright. Finally, no exponents, we get to the parentheses. Now inside the parentheses, we're lucky here if we had more than one operation, then we have to start all over at level 1. But since we're just adding 30 here, the inverse is to subtract 30. So 30 minus 30 is 0, so we have x is equal to negative 23. So reverse PEMDAS always, I believe, will always give you the correct answer. Alright. Now to begin this lesson, the inverse basically means the opposite. So I always like to tie in things in real life. So in real life, you always have the opposite of something. So if you are sad, then the opposite is to be happy. And there are many other examples. If you are hungry, you are starving, the opposite is that you are full. So happy, sad, that's the best example. Same thing in mathematics. There's always an opposite of something in mathematics. Well, maybe not always, but usually there always is. So the opposite of addition is subtraction. The opposite of multiplication is division. Now remember this, if we square something, such as 3 squared, we get 9. How do we go back from 9 to 3? Well, we take the square root. Now, what is this right here? F of x. Well, this basically represents a function. What is... Have you ever thought about what is the opposite of a function? In other words, what is the inverse of a function? Well, let me go ahead and give you the symbol for it. Well, the symbol is F inverse of x. Now, it's very important that you say this correctly, and I'll write it down. And I had you guys write that down in your notes. F inverse of x. So basically inverse means the opposite. F inverse of x. So say this correctly. I will always correct you if you say that wrong. So F inverse of x. Now, if we look back to what functions represents, functions basically represent equations where you have an input and you have an output. So finding the inverse of a function isn't as simple as just writing this right here and then saying you're done. That's the opposite of a function. We have to look at the function cycle because a function is an equation. So now you have to ask yourself this: what is the opposite of this equation, how do you even begin to think about what the opposite is? So let's go through the function cycle and let's put this in table form. So remember, we take each input, plug it in for x, and we get our output. So the first one is 0, 0. If we plug in 1, we get 2. If we plug in 2, we get our output 4. So here is our table, 0, 2, and 4. So again, here's the function, and here's the inverse, the opposite. If we look at the function in the form of a table, what do you think the inverse of that table, the opposite of this table, is going to look like? Now, I had some really good guesses. Well, you basically take the numbers and make them negative. That was a very intuitive guess, but not in this case. It's actually another simple way. All you have to do to take the opposite, the inverse of a table, is to interchange the x and the y. So you see what I did here? Now my y is going to go as my input, and my x is going to be my output. So I interchange x and y. So it's actually very simple to go from a table and find the inverse of that table. It's basically switching the x and the y. Interchange the x and y. Now remember, from a table we can go to ordered pairs, and basically we take the ordered pairs from the table, 2, 4. So again, I'll write it here, 0, 0, 1, 2, and 2, 4. Now how do you think I'm going to find the inverse of these ordered pairs, the opposite? Well, you're basically looking at the inverse of this table and writing out the ordered pairs. So you can see 0, 0 basically stays the same, but when we go to our second ordered pair, we basically interchange the x and the y. So here we go from 1, 2 to 2, 1, and then 2, 4 to 4, 2. Okay, that is done. So tables and ordered pairs are very simple to find the inverse of. Pretty simple. Now what if we take those tables, and so here is my f of x equals 2x. What if I take those points and the table from the inverse and plot those points? So I had 0, 0, 2, 1, and 4, 2. There's my graph. So if we take a look at this again, well, let's put these side by side now. 2, 2, and 4, 2. Those are my graphs side by side. Now, what we want to do is focus on the equation. So here are the points from my inverse. So I took these points from my inverse, from my ordered pairs, and ultimately what I want to do is, how do I find the inverse of an equation, the inverse of a function, the opposite? So let's go and take this right here and figure out what is the equation going to look like. So to do this, we have to go ahead and find our two ordered pairs. Let's keep it simple for ourselves. Let's use 0, 0, and 2 and 1. So 0, 0 is my x1 and y1, and 2 and 1 is my x2, y2. So what we have here, when we plug them in, we basically have 1 minus 0 and 2 minus 0. So we can see that our slope is m is equal to 1 over 2. Alright, we found the slope, but we need to plug that into the point slope formula to find our equation. So We plug in 1/2 in for m, x minus 0. Let's use the simplest one, which is 0, 0. So x1 is 0, y1 is 0. So when we simplify this, we'll distribute the 1/2. And ultimately, what we are left with is 1/2 x. So the inverse is 1/2 x because we're going to replace this y with the inverse. So our original function was f of x equals 2x, and now our inverse is 1/2 x. Do you see something here? Just by looking at these right here, is there some sort of pattern that we can look at to find the inverse? Well, look at the slope. Here the slope is 2/1, and now the slope is 1/2. Is it as simple as that? Is it as simple as just flipping over the slope and that's going to give you your inverse? Let's take a look at this example. Well, looking at that pattern, well, I guess the inverse is going to be 1/2x plus 1. Nope, that's not right. But you do have one thing correct. The inverse, whenever you have a function and you look at its slope, the inverse is always going to have the opposite, the reciprocal of that slope. So it's that's a pretty interesting pattern that I've been observing. The inverse is always going to have the reciprocal of the slope. But it's not as simple as that. There's actually going to be 4 steps in order to find the inverse. So let's go through those 4 steps. Step number 1, substitute y for f of x. So basically you take f of x and replace it with y. Y equals 2x plus 1. Pretty simple. We're ready for step 2, solve for x. So we're going to take y equals 2x plus 1, and we're going to focus on this side, solve for x using reverse PEMDAS. Now, don't let this y throw you off. Look, going all the way back to our example, if we had y here, it would be on this side right here. Y would, instead of having 17, y would be right there. But basically, all we did was just focus on this side that has the x. So that's what we're going to be doing. Just focus on the side where the x, and we're just basically going through all these steps in order to get x by itself, to solve for x. So don't let that y confuse you. So here, let's go through the steps. Just focusing on this side. So if we go ahead and go through reverse PEMDAS, we look for addition or subtraction. Here we are adding 1, so the inverse is to subtract 1 from both sides. So 1 minus 1 is basically 0. Now what do we do here? Well, we're taking y and we're subtracting 1, so we're going to have y minus 1 equals 2x. Okay, so that's what we have. Now, did we solve for x? Nope. X is we're still doing something to x here. We're multiplying by 2, so that leaves us to our second level. What is the inverse of multiplying by 2? Well, that's to divide by 2. Now, make sure when you go to the other side, you divide the whole thing by 2. Not just y over 2, or not just y minus 1 over 2. The whole thing over 2. Okay, so now we have 1 y over 1, y minus 1 over 2 equals x. So step 2 is done. We solved for x. Now we're ready for step 3. Interchange x and y. Remember, what does interchange mean? Well, look at what we did here. We basically, to get the inverse, to get the inverse table, we just basically switched x and y. So that's what we're going to be doing for step 3. We're basically going to take y and replace it with x. We're going to interchange it with x. So x minus 1 over 2 is equal to, instead of writing x, we're going to interchange it with y. And so here it is. Step 3 is done. Basically switch x and y. And finally, step 4, replace y with f inverse of x. So x minus 1 over 2 is equal to f inverse of x. So this is the final answer here. Now, this is just my preference. I would like for you to write f inverse of x first and then x minus 1 over 2. Are both of these the same? Yes, they are. I just prefer this one. And so those are the 4 steps to find the inverse. Now, you may be thinking, well, does ReversePEMDAS really give us always give us the correct answer? Well, let me go over one example that might have confused you. In that example, so I basically had you do page 53, 328. One example that you might think, maybe this one, ReversePEMDAS does not work. I'm telling you, it does. Okay, so let's go through the 4 steps. First step, replace f of x with y. So I have y equals x plus 1 over 6. Step 1 is done. Step 2 is to solve for x. Okay, so ReversePEMDAS. If I'm solving for x, the first thing I want to look at is addition or subtraction first. Well, you might say, well, here I'm adding 1, so by ReversePEMDAS, the first thing I should do is subtract 1. Take careful look at this. This x plus 1 is part of a fraction, which specifically is the numerator. So 6 is the denominator and x plus 1 is the numerator. So if this is a fraction, then basically we have to put parentheses around the x plus 1 because everything on top goes together. They go together. You can't separate them unless you get rid of the fraction first. So something very important about this is whenever you have a fraction, everything in the numerator stays together. So that's why we have to put parentheses every time everything in the numerator. So this is kind of an unwritten rule. Every time you have a fraction, the numerator stays together. Numerator in parentheses. I hope, well, I didn't spell it the best way, but the numerator is supposed to be in parentheses all the time. So now, ReversePEMDAS is still gonna work because notice we don't have addition or subtraction because this addition is inside the parentheses, which is last. So going to the next level, multiplication or division. Well, we see that we're multiplying by, dividing by 6, We're dividing by 6. And so what is the opposite of dividing by 6? Well, you multiply by 6. And so here we have 6 times y, so that's basically 6y is equal to x plus 1. Alright. No more multiplication or division, no exponents. We finally get to the parentheses. So notice now that we don't have a fraction anymore, so that means we don't have to have the parentheses anymore. And so, but inside the parentheses we do have just one operation. So what is the opposite of adding 1? Well, that's subtracting 1. So what do we do here? 6y minus 1? Well, it's basically 6y minus 1 is equal to x. Alright, and finally, step 3, you interchange x and y, so we have 6x minus 1 equals y. And finally, the last step, you replace y with f inverse of x. I like to write my f inverse first and then write 6x minus 1. Here is my answer. So, very important, whenever you have a fraction, the numerator always goes in parentheses. So reverse PEMDAS prevails. It's always going to work. Alright, so that's how you find the inverse. Thank you for watching.